Hello, this is Patrick W. Crawford, Moo-Ack Productions, and this is a walkthrough or behind the scenes of a photo edit I did 2 weeks ago called Time-Lapse Calculus. The premise is that I woke up early one morning to take a time-lapse of the sunrise of Boston from nocturnal twilight to about 10 degrees of the sun above the horizon. And afterwards, I wrote a program in the language called MATLAB to stitch the different frames together into a single unified image. So if I just search the duck out here, I can make it to my DeviantArt page where I've posted the time-lapse picture. And here you can see the final output. Actually, 4 different outputs. Before I go into detail of what the program actually does, let me try and explain loosely how it was done. Basically, the idea is that each image is representing a time. So in the program, what I do is some way take a part of the photo at one time and a part of another photo of a different time and stitch it together. So if you look here, the most simplest one is the gradient one, bottom right, which I'll zoom into now. So as you can see, it appears that the scene gets lighter from from the right to the left. And what's actually is happening is I've taken strips of each of, not every image, but every interval image. I've taken a strip in time to the earliest point that I started the time lapse to the latest point. So if you zoom in farther, you can sort of see there's vertical lines that kind of represent where the division is made. All the program is doing is taking a column of one image, so for the very first image, it will take just the very right, say 8 columns of pixels and copy that to the final image. For the next image, it will take the row or columns 16 through 18 of that image that was, say, 30 seconds later, and paste that into the final image. So basically it's taking strips from each image as it goes across. So what you have is one image that represents the whole sunrise sequence over time. Or this is actually just a part of the sunrise sequence, otherwise the photo is becoming too overexposed. So as you see here, the way I've set it up is that I input in the program I wrote a image file, which it converts to a black and white image, and it reads the image as basically how to map the time. So for example, the one I just showed you, the mask I would have used for that one would have been a black and white gradient, starting with black to the right and white to the left. So basically, as it goes through the image, it corresponds every black. Basically, each pixel is associated with a number of 0 to 1, which is basically how black or white is it. 1 being white, 0 being black. So if say the color of the image at this pixel right here were 0.5 and the mask I input, then it would know to choose replace that pixel with a photo that was taken about in the middle of the sequence. So it's probably just as well easy to show you a demonstration of this. So over here I've come into MATLAB, which is a commercial program, so I could release the code if I want to, but not many people would be able to use it. But here's the script I wrote here, and if I just run it, we'll start the interface bit of it, which is basically the first part is I choose a mask image. So let's say I want to choose I don't know, let's try this one. I don't even remember which one this is. If I press open, it will next it will ask me to choose which folder, and this is the folder that contains all of the images I want it to do the time-lapse calculus over, I guess you could say. So I press OK for that sequence folder, and then it will display the mask that I chose, which I don't even know what it looks like yet. Oh, that's interesting. It looks interesting. And so now it's showing me what the mask looks like, and I can see if I want to invert it or not, which is an option here in the interface. So just looking at this weird mask I've chosen, like I said before, white would represent a later point in time, i.e. the latest point in the time that I chose for that image sequence. Black would be like the very first instance, and gray something in between. So since I did a time lapse of the sunrise, or at least from a darker moment before the sun came up to a later moment, dark would be a darker part of the scene, and white would be a lighter part of the scene where the sun sort of come up already. So I can expect if I keep it as like this, then this part will be a dark part of the scene, this will be a lighter part of the scene, and this will be sort of in the middle. So I'm going to actually invert this by pressing when I program this in. So basically it will do the opposite of this. So it'll make this part white, it'll make this part black, and this will stay more or less gray. So that means this will be the lightest part of the image, this will be a dark part of the image, and whatnot. So I will press enter, and it will start processing. So I won't show you the whole process while it's processing this, but basically it has to shift through every individual 10 megapixel picture and process where the corresponding gray value corresponds to that image and copy the pixels over. And so I think this sequence has about 170 images. I've cut it down from the original total of like 600, so it's still gonna take a long time. Thankfully, since I don't actually own MATLAB, I'm running it through my school server. It's my computer's not actually running this task. I'm just getting the feedback information off the server, so it's more unfortunate for them. So we'll come back in a minute once it is complete. All right, now that the program has finished running, we can take a look at the results. I can hope at this point you haven't already been scared off by the programming. It's whatever. So you can see up here I wrote a little bit to sort of tell you how much of it is completed after a certain amount of time, because it does take a while. As you see here, I've also clocked it, so it took about 14 minutes. Again, these are 10 megapixel images, 170 of them, or however many it was. And so yeah, it takes a while. Here you see a number of variables, but I'm just using that right now to figure out which one I want to show. Export, I believe, is, you can see the dimensions there. So that's X component, Y component, other way around, and then the 3 channels for RGB. So this should show us the final results in a second. And so this should be, like I said, the exactly, the light parts of the image were to the left, and the dark parts over here and here, or in the gray parts up here and whatnot. So this is sort of like midway through the process. You can see it, and here I guess it was a little bit lighter. The inverted mask was a bit lighter, so it's a little bit later on when the sun is rised up, and again over here. But either way, you can still see that well, it's integrated it quite well, hence why it was called time-lapse calculus. If you can zoom in, though, I'm not sure if I trust this program enough to do this. Oh dear. You can see that it's a bit blotchy. Let me find a better place to zoom in. Yeah, this would be a better spot, I guess. So I'll find another place later, but you can sort of see that like it literally is just copy pasting pixels from one image to another. So I haven't added feathering or sort of smoothing effect between the images. So if there's some noise, it looks a little bit uneven if you zoom all the way in to the pixels, more than a normal image would. But if you zoom out, then it looks pretty much all right. So for those who are curious, I am going to do a quick run through of how I programmed it. If you're one of those people who are scared by programming, leave now while you still can. Although I'm not going to go into much detail. This was the first image manipulation programming I'd ever done before, and the reason I chose to do it in MATLAB is just because from school I knew it had some image functions that worked easily. I tried doing, or rather installing Python imaging library before. It was never successful, so I was kind of daunted by it. But this one I decided, hey, I'll just try it out, see if it works, and if it doesn't, oh well. And if it does work, it'll be something pretty cool. So it did work, so that's all good. So make this a little bit longer, whatever. So this first part is just loading the files. This is the UI stuff, getting, which to use the mask for, finding the step size and stuff I'll explain later. The important part is this loop here. So ignoring this first part, this just tests to see if it's at the 25% or 50% or 75% way. Basically what this does is it starts, it first opens the first image of the sequence it loads, which would be, if I go into here, it would be just this first image here, which it'll show down there in a second. So that's the darkest point or the earliest point of the time-lapse sequence. So that is set already equal to be the exported image as the first step. So then what this loop does is it goes through n number of images, which is the number of images in my sequence here, which it doesn't say about, but 170 or something or so. Yeah. It goes through n number, but it starts at the second image to start actually processing. So basically what this means is that even if there's some transparency issues or for whatever reason it might skip a pixel, it shouldn't. But it will always have the background of the first image set as the background. So it starts on the second image, which will be the second time interval or 30 seconds after the first image to start going through the processing. So say we're on that I equals 2 or the second iteration. It will load the second image file, get the name, save it as this, and then it will go through basically a loop for 1 to x, where x is the number of x pixels of your output image. It'll go likewise to the number of y pixels or the columns. So basically it's going through every individual pixel of the mask, the starting mask image that I supplied, which is equivalent. It's resized. It's always resized to be the same as the dimensions of your output or the starting image that you export. So it's going through pixel by pixel, n minus, ignore that. Ignoring this as well. Basically, the key part is here. So basically what this does is step up here was defined to be, I think it's, scroll up a little bit. Yeah, step is basically the max value of the red mask image over the number of images brought in. So the max value, that would be the highest value of the mask as an individual pixel, as in it would be like 1, I believe it is, or 255 it was RGB. And basically that's like, it's normalizing the range over which each individual image is going to be assigned. So what this inequality here does is it checks to see if the value of, because it's actually going through each pixel of the mask image and seeing if it is in between basically the range of values for which an image can be it's not explaining very well. So okay, let's say that you are doing a sequence of 4 images, all right, and that your mask image goes from 1 to 100 in value. So i.e. 100 would be a white pixel on your mask image, 1 would be a black pixel. So if it goes through each pixel and it comes across a gray pixel that has a value of 40, then this inequality will see, well, first it will have divided each image to be a range or a number, or the step size rather. And so it's seeing that, okay, you are in the range of 25 to 50, and that is equal to the color image of the mask. Therefore, I will copy the pixel of that image, as in the second image of your image sequence, and copy it to the same pixel location on your exported image, which is here. And so then it does that for, I mean, obviously if you have more images, then it'll be a finer division, like 0.1% or, you know, whatever. And so it'll just go through that for every pixel of the mask image. And it's actually most optimized this way because this you're only loading each picture once. So I load the second picture up here, and it goes through every location to see where the second picture would be used as that color. And so then after that, it clears and it loads this next picture, because otherwise you have huge memory issues and it would take forever. And that's basically the extent of the program. It's really not that complex at all. And so afterwards, it just writes it to the image file and does the other processing, like saying how long it took and whatnot. So that's basically it. Again, this was just an experiment, something I thought, hey, it'd be fun to do, or at least intriguing to do. I've never done something like this before. So I hope you enjoyed it. I hope you thought it was interesting. And be sure to check it out or download it on DeviantArt. I doubt I will, but it is a possibility that someday I will be ambitious enough to learn how to use image processing in other languages, which means if I were to do this, I would learn the native language for GIMP and make this as like a plugin there. So you could take your own time lapse and supply your own mask image to see how it changes over time. Anyways, thanks again. This is Patrick W. Crawford, and I will see you next time. Moo-Ack.